So question 4005 helps us to start to see what happens when we're running Wireshark and capturing traffic that is encrypted. If you download the RSA Snake Oil 2 PCAP and open that, you'll see something similar to this, where the clients talk to one another. They make their initial communication with one another, where they'll say hello to each other. Then they'll exchange keys. And then the rest just says application data. We don't get to see what's happening anymore. All that we know is that two devices are talking to one another, and there's no understanding. We can't see what's happening. Wireshark is not able to decrypt traffic by default. You need the RSA key in order, or you need the private key in order to see the traffic decrypted. Without the private key, any HTTPS traffic or anything that's encrypted will not be readable by Wireshark. What you can do for this is download the key file, and we'll import it under Edit Preferences RSA keys. So here's the preferences. Here's RSA key. We'll add the new key file. And that's the one that we just downloaded. With that in place, you should now be able to see the traffic decrypted. I'm not sure why mine is acting up. But it seems to be acting up.
Must have blocked your screen share because of all the X-rated content.
Oh, yeah, maybe that's what it is. Because there it is, there it's back.
Yeah.
They're coming down on us. I'm showing you how to decrypt traffic. They're like, no, don't show them. Don't show them the secret. Once you have the traffic visible again to you, so this is the before, this is the after, where you now get to see the traffic much more legible. There is a page that was not retrievable by the server. So remember that HTTP status codes, that's really what you're looking for. Anything that is 200 is okay. Anything in the 300s are redirects. Anything that's 400 is client error, and anything that's 500 is server error. So if you find any status codes in the 500s, that should be an indication to what page was not retrievable by the server. (5001) begins looking into the protocols themselves. The first part kind of has a review of the two models and what protocols fit within them. Next, you have a visual of the resolution process. Whenever a user requests a site, this is the process that the system takes. And how a client requests a server. If all goes well, it gets the information it needs and talks. We're going to compare two files, Riverbed 1 and Riverbed 2. And compare their two browsing sessions. Riverbed 1 visits a website. Riverbed 2 revisits the same site after 89 seconds. That's the comparison between Riverbed 1 and Riverbed 2. This one happened first with DNS cleared and browsing history cleared. DNS 2 happened 89 seconds after the first. In Riverbed 2, the first packet goes to /us rather than just /. What packet in Riverbed 1 is the reason why this one did not go to that site, but instead went to this site? So let's download these. That was a little confusing, but we'll make sense of it. Here is Riverbed 1. There is the GET request, something we expect, asking for the home page. There is also the /us or /us, maybe that's what that is. Riverbed 2 opens with requesting the /us page. So what happened? What packet in the first trace file, Riverbed 1, is the reason why Riverbed 2 was able to just start from get /us/ rather than the /. $5,002 continues the comparison between those two files. Between them, what higher level OSI layer protocol was greatly reduced? This question, 5002, is reminding you, or should be reminding you, of a prior question that we did where you looked at the protocol hierarchy. So I would suggest for 5002, compare the protocol hierarchy for Riverbed 1 and Riverbed 2. You can use the chart above to help you answer the question. I think we'll stop the recording right there.